So remember, in our projectile motion, we've said that your horizontal has no acceleration, none, in the horizontal direction, which means that the velocity is constant. And that results in you having a linear displacement. And your vertical project has a constant acceleration, which then means your velocity is continually changing in the same way, which means it's a linear function, resulting in your displacement being quadratic. Now, we will now look at this in terms of your ST, displacement time, VT, and AT graphs. And we'll do separate ones for horizontal and vertical. Now, remember from the earlier page, we said that your horizontal over here has no acceleration, yes?
Yep.
So what that then means for your AT graph is, well, very simple. There's no acceleration. It's 0, as expected. And that's your AT graph in the horizontal direction. Now, if you've got no acceleration, that of course means that your velocity shouldn't change, and it doesn't. That's why it's always at ux, the initial velocity, otherwise known as v cos theta, which means that your velocity time graph will just give you a straight line that is flat because it doesn't change. So this is going to be ux, or v cos theta. Now, because your velocity is constant, that's going to result in your displacement time graph just moving up, increasing at the same time each and every time. And that will give you just a straight line that looks like that. So before we move on to the vertical, it might help just to sort of bring in a little bit of maths and just write out an equation. So this is AX, this is VX, and this is SX. We know it's AX equals 0, VX is V cos theta, SX equals VT cos theta. So this is A equals 0. This is all in the X direction, of course. Then V equals, well, V cos theta. And for all intents and purposes, you can think of that as some constant K, right? So we're kind of drawing a Y, because V is the vertical axis. We're just drawing here Y equals 0. Here we're drawing Y equals a constant. That constant is V cos theta, or UX, right? It's just Y equals a constant, so it's a flat horizontal line. And over here, we're saying that this S equals, well, V cos theta times T. Or in other words, this is a constant times T, which is why that is just a straight line passing through the origin. And not only that, but we know that the gradient is V cos theta, which is the velocity. So you might remember from your term 1 work that the gradient of an ST graph is the velocity, and the gradient of a velocity time graph is acceleration. Of course, the area under the curve goes the other way. So the area under an AT graph represents the change in velocity, and the area under a VT graph represents the change in displacement. Okay. With that bit of revision, let's now move on to the vertical. So the vertical, we have acceleration is negative g. Keeping in mind that it's negative, we'll need to draw a line like that. And remember, this a equals negative g. All right, and with that in mind, we understand that your initial velocity is v sine theta. It's going to start with some upward velocity, but then you're going to get minus gt, which means it's going to get slower and slower. And so that means you will now go down like that. So it's going to look at this as v sine theta. And this gradient is going to be negative g. For the same reason as we said here, right? The gradient is going to represent the acceleration. And we know that this v equals, well, v sine theta minus gt. And you can think of this again as, well, y equals sort of mx, where m is negative g, plus b, where the y-intercept is, well, that. And so this one, it might help more to look at this one, looking at the formula, because it might be difficult for you to see that one there. But basically, it's a quadratic, which means it's a parabola, and it will basically look like this. And so these are the ST, VT, and AT graphs for a particle undergoing projectile motion. The key takeaways that you should have are, again, what we said before, that this is constant velocity, and this is constant acceleration. This is no acceleration. Those are the key points that you'd like to have. Of course, the follow-on results are that you're going to have this sort of velocity vertically, and you can have this sort of displacement horizontally, and this sort of displacement vertically. Okay.
Yeah.
Any questions with that?
Nope.
Good. So let's take a look at some animations now that hopefully will make this a little bit clearer. And that should put you in a good position to start doing some of the more basic problems with regards to projectile motion over the next few weeks.